Hello, am I audible to everyone?
Yes, sir.
Yes, sir.
Yes.
Okay, first of all, happy Deepavali to all of you and good afternoon. So, it's already 4 minutes past from 1. We can start our discussion, and if more people join, then they can catch up. Okay, so since this week, JKB sir did not send any assignments, and so what we can do two things. I have planned two things. One thing is that I can discuss uh, several mathematical concepts such as gamma function, beta function, these things with you, because I have heard that these things have not been done very rigorously in the class. Or if you have any specific doubts, any conceptual questions, you can ask and we can discuss that. So which one would you like?
So I think we can discuss those special functions of mathematics which you just mentioned.
Yes, sir. That will be better.
That would be
Okay,
better, I think. Yeah.
okay. So, okay, fine. Then you tell me up to which point you know the gamma function or beta function. I mean, you just know the definition, and do you know the properties of gamma function?
We know the definition, some basic properties, and some special values which were required during the derivation of those Maxwell-Boltzmann
Have
equations.
you proved the properties?
No, no. I mean,
No, no.
I have just
Just
used those
mentioned.
properties, but yes, yeah,
Just mentioned. Okay.
yeah.
Okay, fine. I mean, since I do not attend your classes, so I don't know exactly what have been studied. But okay, so very good. We can study that. Just let me share my screen. Okay, so since it is just after the Kali Puja, you might hear some dhaker awaj and all these things. Okay, fine. Is my screen visible? A blank white screen is visible to all of you?
Yes, sir.
Okay, fine. So what is exactly the gamma function and why do we need this gamma function? Okay. So apart from just to give you a feel what gamma function is, suppose I am just writing, has any one of you used or familiar with Mathematica? It's just a mathematics software.
Yes, sir.
Yes, sir.
You are familiar with that? Okay. Okay. So what I will do, I will just plots. Am I supposed to big the if this font you are if this font is visible, the writing is visible,
Yes, it is visible.
or I should
Yes,
make
sir.
it bigger?
No, sir. It is visible.
Visible, no? Okay, fine.
Yes, sir.
So I am what just observe what I am just let me plot a thing. Okay, this is gonna be a very informal kind of discussion today. 1 to 50. This is the problem. More people are joining late, and I have to just go back every time and approve them. Okay, my screen is visible, no?
Yes, sir.
Yes,
Okay.
sir.
So what I am trying to do here, I am just plotting n minus 1 factorial. Okay. In the x-axis there will be n's. N mean 1 to 1 to 50, 1 2 3 4 5. In the y-axis corresponding the previous numbers factorials are being plotted. Okay. If I just make the plot, make it a little beautiful. Okay. See, this in the x-axis, in this x-axis, the number, natural numbers 1, 2, 3, 4, 5 up to 50. This is plotted. These are plotted. In the y-axis, the corresponding numbers, previous number. Suppose for n is equal to 20, 19 factorial corresponding to n is equal to 20, 20 minus 1, that is 19 factorial is plotted. Okay. Up to this point, any doubts you have, or any difficulty?
No.
Sorry?
I said no.
No. Okay. Now I just I plot what is just gamma function of n. You can see these two plots are exactly very similar, and to my just believe me, these are two identical things. Okay. So this is basically what I have not entered into the definition of what this or this that, but what how does gamma function look like can be seen by this. So this is nothing but, if you just forget the second term, what is gamma and all these complications, you see this is nothing but for integer numbers. Just for the very clear, just for the time being, suppose we have just plotted only the integer numbers in the x-axis and the previous numbers factorial n minus 1 factorial. For n, the corresponding y-axis should be n minus 1 factorial. This is the gamma function for integers. But if I just join, if I somehow just join this plot, just log, no, please, joined. Okay, if I can, no, please log plot, and I join. If I just join these things, this is basically how gamma function look like. But there is a catch, that now when we try to define a function, gamma function, which looks like n minus 1 factorial for integer values, we can also define gamma functions for non-integer uh, arguments. For n, gamma n, if we just plot this gamma function, if we just plot gamma of some x for x 1 to 100, make it a log plot. This is basically what gamma function looks like, and this is valid. This gamma function is valid, or so to say defined, for every positive values of n x, for x or n, whatever the argument is, greater than 0. Even if the non-integer values also, we can define gamma half, we can define gamma 3 by 2, we can define gamma 12.64646, etc. Okay. Up to this, any clear? Then I will stop share and just I will do calculations on my tab. Up to this point, anybody has a doubt? Any questions?
Sir, can gamma take complex values?
Yes, they can also take complex values, right? But I have not said it yet, because in this plot I have not make any complex for any complex values. But yes, gamma function can take any complex values, but the integer part should be non-negative, must be non-negative. Okay. Any other queries? Anything? See, if you do not speak up, then it will be very difficult for me to understand whether you have understood, whether you have not understood anything.
Yes, understood.
Okay, then just let me okay, then let me stop share from here.
Sir, I have one question.
Yes.
Sir, why you are doing log plot means why is it always necessary means I have seen not in this case but in many other cases they prefer log plot.
Oh,
What does log tells us?
yes. So the thing is that suppose, yes, is my some I'm scribbling something, is that visible to
Yes, sir.
you?
Yes, yes, sir.
Ah, okay, okay, fine. Let me just rotate this thing so you can. Okay, just tell me the difference between n factorial minus n minus 1 factorial. This difference, okay, this difference is small. If we increase n from say 1 through 3 4 up to 100, this difference will increase or decrease?
Increase.
Increase very much more rapidly. So what happens if I just plot, I mean, an factorial thing, or this is same as exponential thing, some e to the power x minus of e to the power x minus 1, some exponential thing. Okay, I have just in the x-axis, suppose I plot n is equal to 1, 2, 3, 4. Okay, right? Now if I just in the y-axis, if I just plot some n factorial, what happens? The curve becomes, after certain value, it starts to grow very rapidly. Okay, now if I just plot for a very high range, because the as I just grow, as I increase in here, n is in the x-axis. If I just grow in, now this interval is fixed. No, this is just n is equal to 1, right? This is also n is equal to 1. Delta n is equal to 1. The difference is 1, 1, right? But in the y-axis, the difference increases a bit, because this is the in the y-axis, this should be the interval, right, between two consecutive, because we are plotting a curve. This tells us y is equal to some x factorial. This is the, suppose we are plotting this thing, bro. No. So what happens if we just suppose we are plotting for a very high range, this n is equal to this x is equal to some, say, 1 to say 200, and this is x factorial, y is equal to x factorial. You see, up to certain, because you see the curve will look like this, or more sharp, this kind of sharp, because so this kind of the curve will look like. Why? Because you see, for x is equal to 1 to 200, the value of factorial will be very higher. I don't know, I suppose for 200 it is 10 to the power 50. We have to show all the values taking from 1 to 10 to the power 50 within a single curve, right? In the linear scale, where all the this thing, all the smaller parts, they are suppose 1 or 10, but at the same interval. But if we just take a logarithm of this, if we take the logarithm of this, uh, plot in the log plot, then see how these things become beautiful. If you just take log both sides, log of y is equal to x, right? Or or suppose you don't do that, you just plot the plot will be log y is equal to x, and you just plot. There will be a beautiful plot. Just take the logarithm of 1, say this is 10, this is 100, and this is some thousand kind of thing. Now we can, if you just invoke the logarithm here, because you see the difference, the main point is, the main point being the difference in the y-axis, this thing, this difference in the y-axis, this does not change proportionally to n. No, here the same case lies also here. Okay, as as n increases, this difference increases rapidly, exponentially. That's why we take logarithm. Suppose we take 1 here, take some 10, we take 100, we take 1000, and this thing we can increase. Then you can observe a beautiful curve plotting pops up. Am I clear, or am I able to succeed, because succeed in
Yes, sir, yes,
telling
sir.
you? Okay, because the thing is
Yes,
that
sir.
when you
Means we
plot,
can.
yeah, when you plot this kind of thing, an exponential on a factorial thing, in the, as you just increase the x, go higher and higher, the difference in 2 points in the y-axis, this becomes very large. So for n is equal to 100, n is equal to, say, just let me clear, in the normal plot, normal linear plot, sub n is equal to 1 2 3 4, if in the context of, say, 50 to 60 to 70, the difference, the difference of 2 points in the y-axis, that is very high. So because this is very high, the curve, or see, for for 51 to, for 51 to 52, suppose I am just taking this to be 55, 55 to 60, for 52 to 54, suppose 54 lies here, 52 to 54, the factorial difference is very high, such that, so that the points will lie here and here, and the curve goes like this, almost a very sharp rising curve. Okay, that's why the thing is, we can take logarithm in order to invoke that difference in y-axis also. In the, if we make just this axis a logarithmic axis, then this curve will be smoothen out. Okay, clear up to this point?
Yes, sir.
Yes.
Okay, okay. So okay, suppose I define, no, where it is that, suppose I define this gamma function. I i define some function, some gamma function of some z. My minded, z could be a complex number also. This is defined as integral 0 to, is my writing visible to all of you?
Yes, sir.
Okay,
Yes, sir.
yeah. 0 to infinity, some x to the power z minus 1, e to the power minus z, sorry, e to the power minus x dx. This is the definition of gamma function. Now we have to ensure that this gamma function behaves like n minus some z minus 1 factorial, right? We have to ensure that. Suppose what we do, we replace z by, we try to just we try to relate gamma z to gamma z plus 1. Suppose I write gamma z plus 1. What happens is that 0 to infinity x to the power z e to the power minus x dz. That happens, right? You do. Now we want to relate this with gamma z, right? So what now? Now I have this x to the power z in the argument, and x to the power z minus 1. So how do I just step up from this x to the power z to x to the power z minus 1,
Integration by parts.
right? Suppose we do integration by parts, and you know this what this rule calls this in 11 and 11 12 we have learned, no, what this rule calls this first exponential, the first function, I mean the function, what should be the first function and the second function there.
Inverse.
Yes, I left.
Yet.
Liet, no,
Yet.
logarithmic inverse, then
Algebraic,
algebraic,
trigonometric, exponential.
trigonometry, exponential. So exponential should always be the second function, no.
Yes.
So suppose this is my first function and this is my second function, this is 1, this is 2. So I just what can I write? This is x to the power z integral e to the power minus x dx, and my limit should be from 0 to infinity minus 0 to infinity. And now we can take ddx of x to the power z integral of e to the power minus x dx and the whole this dx, right?
Excuse me, sir.
Yes.
So for the gamma z plus 1 function, is the operator is dz or dx?
No, no, d. Sorry. Oh, I have written dx. No, no, sorry, sorry. Yeah, thank you.
Yes, sir. Yes, sir.
Sorry.
Yes.
No, how should be dz, because z is integrated and this is a function of
Yes, sir.
z.
Yes, sir. That's
No,
why
no,
I have a confusion.
no, no, no. Sorry. Yeah, thank you. Okay. So if we just do this integration, what will you get? This is e to the power minus x minus of x to the power z e to the power of minus x from 0 to infinity. Minus of, now this is what happens here, this is a z coming because of the integration, because of the differentiation here, and we can just write it to be, and this should be another minus, so this is becomes plus because another minus is coming from here, exponential. Okay, so 0 to infinity sum x to the power z minus 1 e to the power of minus x dx. Okay, so now what happens is that, see, at x is equal to 0, at x is equal to 0, this function vanishes, no, because x is equal to 0 and x is sitting here, this will make the function 0. But what happens is at x is equal to infinity, right? Now you see, this is a trick here. You know that x is equal to x to the power z e to the power of minus x. Let me make a plot of how that looks like. Plot of x to the power of z multiplied by exponential of minus x from x 0 to say 100. Oh, sorry. X to the power of no. Yes, for suppose z is equal to 20. Okay.
Sir, so we can't see.
Sir, we
You
are
can,
seeing the
oh,
whiteboard,
you
sir.
can see. Okay, okay. No, okay. So just let me make this plot in here about. Suppose this is x to the power z e to the power of minus x. Or what we can do, I can just share this screen, but that will be a bit inconvenient, no? You are seeing the screen?
Yes, sir.
Okay. Suppose I'm making a thing a bit bigger. Okay. Suppose I am doing this thing, this z, I will manipulate the z z from 1 to say 20. You see, manipulate. So now you understand the this importance of log plot. No, see how beautiful this is going. Okay. Suppose you see, as x increases, this is the value of x. X axis is the you see my cursor.
Yes, sir.
Okay, see, this is the value of this x axis is the value of x, right? This is the function x to the power z e to the power of minus x, right? You see how I am just plotting it to be suppose I am just plotting it for 20. What does that happen? See, first this function rises because when x is very small, x is very small, no, as x is very small, the exponential function does not play a very vital role here. Then this part dominates, x to the power z part dominates. Okay, now as x increases this part, due to this part x to the power z for any positive z, this part increases a bit first, but after a certain point, exponential function is the mm, most uprising and also the most decreasing function, most dominating function in the whole world. Wherever the exponential function is multiplied with something, it dominates. Either for positive x is exponential to the power plus x, then for x very greater or x very less value also, this exponential function dominates. So although we have an x e to the power of z value rising sitting here, as x increases, x to the e to the power minus x dominates, and this function starts to fall out. As I go on increasing this value more, x 100, okay, this function goes on decreasing 10 to the power minus 38. See, this function, these y-axis values, y-axis values, these are in minus negatives, 10 to the power minus 38. This is very close to zero. So I can assume that if I go on increasing x from 100, say from 1000, see this function, how much it is, how much now this function is at the value of at x is equal to 1000, how much you can see,
Yes, sir. 10 to the power minus 400.
minus 400, nearly, very nearly zero, na?
Yes, sir.
So you all agree, if I just extend this value x to the x to up to infinity, then this value should fall up to zero,
Yes, sir.
right?
Yes, sir.
And just let me just modify this z function a bit. If we just modify a z, then also the function I can you can see that I can modifying z. So see, z is sitting here, x to the power z. Then also the nature of function changes a bit, but the overall nature, the behavior at x tends to infinity does not change. No? Okay, I'm stopping the share now and I'm starting. Is the share of the screen automatically begun? No, it has not begun. Okay. Any doubts, confusions you have regard up to this?
No, sir.
Wherever you have doubts, you ask me, because if I
Yes, sir. Yes, sir.
if we just pass on, then it will be very okay. So wherever the at x tends to infinity, this function first rises. The this broadcasting, the sharing has not begun yet.
No,
No,
sir.
sir.
Oh, this is the problem. Okay, I hope it will begun now.
Yes, sir.
Will begin now. Okay, it has begun. Okay, okay, fine. So this function, x to the power z e to the minus x function, this first starts to rise due to this exponential to the power due to the x to the power z value. But as exponential starts to dominate, this function will fast dominate. This function will decrease fast and go up to zero. Very tends to will tends tends to 0. Okay. So see, both had 0 and infinity. This function, the value of this is 0. The limits is 0. So this whole thing will be 0. Okay, fine. So what remains is that z, and what is this? What is this part?
Gamma z,
Gamma of Z.
This is just gamma of z. So you
some kind
see,
of recursive function.
recursive function gamma of z plus 1 is equal to gamma of z. Now from this, the two different scenarios can happen. Either suppose now what, just, and again gamma z is equal to gamma z, we can write z minus 1 gamma z minus 1, right? And gamma z minus 1 in terms of in terms of z minus 2. What, so what happens is that z minus 1 z minus 2 up to this will be happen into 1 into gamma of 1. Okay, this will just pops up to be now what, you are clear in this thing, how it goes?
Yes, sir.
Okay,
Yes, sir.
okay, because this formula is true for all z, any z. I am just writing it to be for convenient, but means this is all z, means all the z having fractions, z having the complex number, anything. But I am trying to do a similarity between this to be factorial kind of a thing, because this what gives us a feel of how this function looks like. Okay, in for integers. So now the rest of the work has boils down to finding gamma 1. Now you tell me, what is gamma 1? Gamma 1 should be integral 0 to infinity some x to the power of what?
0.
This x to the power of gamma z. Z means 1. No, is this 0?
0. Yes, sir.
0.
This is 0, right? X to the power 0 means 1, and e to the power of minus x and dx, right? So you know that integral 0 to infinity, so it is nothing but e to the power minus x dx, and this is of minus e to the power of minus x, 0 to infinity. You know that at infinity this function goes down to 0 at plus infinity,
Yes, sir. Yes, sir.
and so this gives us nothing but 1, right?
Yes, sir.
Yes, sir.
So just so in place of gamma 1 I will just write 1. So this is nothing but z, this nothing but z factorial, but remember this factorial only for all z that belongs to natural numbers or integers, right? This factorial, this thing also works for the up to this line. See, up to this line, you must remember this, up to this line, this line is also valid for all z, whether it be integer or non-integer fraction. But the moment I write this function as factorial, I'm assuming only this in natural number or integer values of z. But if we don't write this term, then it is valid for all z up to this, because up to this line we have not assumed anything like it is integer or what we call factorial, all this thing, right? This is valid for all z belongs to some complex number or real number or anything.
Yes,
This
sir. I
you
just
know this
want.
symbol for all. This is for all. Uh, you know now this symbol.
Yes, we know.
Yes, sir.
Okay. What you were saying? Sorry.
I was saying that means, sir, for the simple fraction means half. For
Hmm.
half,
Hmm.
how can we do this?
How can I do
Half.
this? Right. Right. Suppose. Let me. Yeah. Let me erase this thing. Okay. If we just not erase, just okay. Suppose you can write for this formula still holds for gamma of some n is equal to some n minus 1 into n minus 2. This value holds up to for up to what? Now the question comes up to what? Suppose n is equal to suppose n is equal to 7 by 2, right? We can write gamma of 7 oh, gamma of 7 by 2 we can write as gamma of 5 by 2 plus 1. Then our n, not necessary n, then our this n, or n, no, n is a very specific kind of a thing for, uh suppose I call it z. N is very specific kind of a thing for, reserved for this natural numbers. This is our z. Now z plus 1. How can I write this? 5 by 2 gamma 5 by 2. I can write it this way. uh, yes, no, anything?
Yes.
You don't agree?
Yes, sir. Yes, sir.
Okay. Again, 5 by 2. I can write gamma 5 by 2 as, you say, what can I write? 3 by 2 plus
3 by
1.
2 plus 1.
I can write this 3 by 2 into gamma of 3 by 2. Now I can write this 3 by 2 as 1 plus half. I can write this 5 by 2 into 3 by 2 into half gamma half. I cannot proceed further. Why? Because the moment I write gamma to be half, to be something plus half, then I have to write minus 1 plus half. No?
No, sir.
No. What can I
Zero
write?
plus half.
We can sorry, gamma 0 plus half. Right? I can write gamma 0 plus half. Suppose. No, see, this is not true, but suppose I write this to be half gamma 0. Right? Now let us see how gamma 0. What is gamma 0? I know, we know that, you tell me how can we write gamma 0? Put x to the power minus 1, right? If I am not wrong.
Yes, sir. Yes, sir.
X to the power minus 1 e to the power minus x dx. Okay. Now let me suppose I make a plot of, say, x to the power minus 1. X to the minus 1 times, suppose, just I will wait for 1 moment. I will show you. Okay. Mm, okay. You can see that the moment I write a negative power of x here at x is equal to 0, this function blows up. I put a 0 value here, because this is integrating, this is evaluating this the function. What does the integration means? Integration means the function, the values of function, the adding up of the all the values of this function starting from 0 to infinity, no?
Yes, sir.
So the moment I this exponential function behaves very good. This has no such this blowing up thing in anywhere. Okay, but the moment I put a negative power of this x, negative power over x, at x is equal to 0, this function go up to infinity. So the values of this function, this thing, this thing gamma 0, this gives me infinity. So I cannot use this, because this formula, see, this formula assumes what, so to say, the convergence of this function. If this function does not converge, the values of gamma function does not exist for that value, and this function does not converge for z less than 0, right? So we cannot proceed after that. So this formula is only valid for z greater than is equal to 0. Sorry, not is equal to 0, for greater than for what?
Greater than 0.
For greater than 0, right? Okay. So now I cannot write all these things. So my whole problem comes, any fraction, see, any half integer forms, I can write up to gamma half, right? No, now just my task is to compute gamma half. How does gamma half look like, right? Fine. Any questions, queries up to that point, up to this point?
Not from my side.
Anyone else? Okay. So let me write gamma half. How does this gamma half looks like? The time is not very much left, so I have to speed up a little bit. Suppose
Sir, we don't
gamma,
have second class.
you don't have second class. Okay, still, but I cannot. We cannot go on forever. But okay, sure. So 0 to infinity. Then how? What can we write? Some x to the power of, say, minus half. No, minus half.
Yes, sir.
Yes, sir.
Okay, e to the power minus x dx. Now you can also say that, okay, when I put now this function also this x to the power minus half, minus this, what can I say, this x to the power minus half is sitting here, x to the power minus half is sitting here, but still I putting x is equal to 0 does not hamper, or does not this, what can I say, mm, this what can I say, this does not hamper, this does not converge, does not blow up this thing, but you see, I can avoid this x to the power minus half by just a simple uh, just simple this change, what can I say, variable change. Suppose I call x is equal to some t square, I call that. Okay, now, mm, so x is equal to x to the minus half would be what? T to the power minus 1. No?
Yes.
Yes, sir.
So, and I just differentiate it both sides. So dx is equal to 2t dt. I put it back here. This gives me integral 0 to infinity. X to the power minus half gives what? T to the power minus 1, or 1 by t. E to the power minus x gives me what? E to the power minus of t square. And this this measure gives me 2t dt. Now you see, this t and this t cancels. Okay, so we can write it to be integral 0 to infinity e to the power of minus some t square dt. Now we can't figure out this integral at all. Also, we don't know how this integral looks like. For this, what I can do, let me evaluate gamma to the power half square. Can I do that? This is just two gamma halves. This is just some what can I, oh, what is that? This gamma half is 2 times e to the power 0 to infinity e to the power minus t square and dt. So I write 2 integral 0 to infinity e to the power minus t square dt. That's square, right? Square. Now I can instead of this square, I can write this function twice, integral 0 to infinity e to the power minus of t square dt in terms of t for convenience, for making for just a different notion. I call it to be u square du, just because the this is just a mere integration variable. This just does not alter anything. Can I do that?
Yes, sir.
Yes, sir.
So suppose, so as these things don't just uh, hamper each other, they are decoupled, so to say. I can just write it to be some t square plus u square, this thing, then dt du, right? Now you see, now this integration is in Cartesian space, Cartesian coordinates. Now if I just make t to be our usual some r sine theta, just turns out variable change. When you appear this kind of integration, e to the power minus a square plus b square, you can just a is equal to r sine theta, y is equal to b is equal to r cos theta. Then then the integration will be a bit easier. Okay, r cos theta. Suppose I can call this, right. Then t square plus u square, this will become simply r square, right? And let me make you a bit clear why I am doing this. See, I don't know how to solve this kind of integration, e to the power minus x square dx. I don't know how to solve this, right? But I know how to solve this how to solve this integration, e to the power minus x dx. That I know, right?
Yes.
But how can I change now? Just if we just have another x dx kind of a thing here, then I can turn this integration to into this. I can do that. Just I will
Yes.
call x squared to be something, some y. I can do that, right? But we don't have any x here, so I we are just trying to put an another this kind of a thing, this e to the power minus r square r dr d theta, right? Now you see how we do that, right? And what would be this dt du? You have you studied this polar in vector algebra? Have you studied this polar
Yes, sir. Yes, sir.
coordinates, Cartesian coordinates,
Yes, sir.
polar, spherical, polar? So you tell me what will be dt du? Okay,
So r d theta dr.
R by 2 sine
okay.
2
Now
theta.
d is equal to sine theta d
R square
theta.
sine theta dr d
Uh,
theta.
this
Yes,
sine
sir. R
theta
square sine
dr.
theta dr d theta.
Okay, plus some cos theta r cos theta d theta. Similarly, from here we can write du to be some cos theta dr plus minus some r sine theta d theta, right? We can do that, and if you multiply these two fellows, we will get r square sine theta. No, r square, just uh, r square dr d theta. No, no, not r square. Why r square will come? R square will not come. What will come? Only r. No, only r, because this r sine theta cos theta. Yeah, only r will come. No, r square will not come. because these fellows will be multiplied this r cos theta with d theta dr. If we just multiply d theta dr coefficient with this and this, if we just multiply, okay, you can check it later on. It will come to be r dr d theta, and if we just put it back together in this integration, so now what will be the limit of theta? Because t goes from 0 to infinity, and theta goes from 0 to what? Acha, no, one thing. I have made a this thing. What we can write before this line, suppose we had this 2 integral 0 to infinity e to the power minus t square du dt kind of a thing. No, can I write this thing to be minus infinity to infinity e to the power minus of t square dt?
Yes, sir.
So I will just, because that makes thing more clearer, so I will omit these twos and I will write to be minus infinity to infinity minus some infinity to infinity. Okay. Now this t square plus u square, the limits of, now you tell me what is the limit of theta?
So sin theta doesn't take infinity, means theta.
Mm-hmm.
Sin theta can't be infinity.
Right. So sin theta's value lies between -1 to 1. How can it take
Yes.
infinity? You see, r, what is the value of r taking? R can take negative values,
No, R is always positive.
R is
but
from 0, 0 to.
r is from 0 to infinity.
0 to
But you
infinity.
see, the moment I define t to be r sin theta, that the value of t can take both positive and negative values.
Yes, but sign can be
But
controlled by the
Sign can be
sign theta.
negative.
R is always positive. So in order to take into account the negative values of t, we must take into account the full the negative part must come from sin theta,
Yes.
right?
Minus pi by 2 to pi by 2.
You can do that, or you can do to some no, minus pi by 2 to pi by 2, you can do that. But the more appropriate thing, because the way we defined our this thing, this is our axis, and this should be our, because this looks like a circle, no? This looks like the equation of a circle. So if this to be theta, and this is our r, and r sine theta, this is our t, and r cos theta, this is u. So the value of theta, what should this value take? Theta
0 to pi.
0 to,
Pi,
if
pi.
the full circle is pi,
Full circle is 2 pi.
2 pi, right? So we can so we should take the value of theta to be 0 to twice pi, right? Okay, so we can write this fellow here, we can write to be no, these are all the things. We can write this to be integral. See, when I just write to be the moment I express this to be in terms of this wait, when can I what can I say, this to be in terms of minus infinity to infinity, but r only takes the values from 0 to infinity, right? Dr d theta integral 0 to 2 pi d theta, then e to the power of minus r square, then r plus, okay, because r dr d theta e to the power minus r square. Now I can make this. So you see, this thing is decoupled. This thing we can evaluate anyway. we can write it to be just twice pi. Hmm? Any difficulty you are having?
No,
Anything
sir.
confusion? Okay.
No, sir.
Okay. So 0 to 2 pi, integral 0 to infinity r e to the power minus r square dr. Now you just put r square is equal to some z, and you are back with this integration 0 to 2 pi integral 0 to infinity some dz e to the power minus of z, and you know the value of this is nothing but what? Just you did it few
One.
moments ago. It is one. So this value is nothing but uh, no, no. One thing should come. A half factor should come outside,
Yes, half
because when
half.
I half half because just the moment I write dr r square to be dz, just differentiated both the in both the sides, 2r dr is equal to dz. This 2 must appear in the this thing. Okay, so this is nothing but pi. So what it was initially, it was just gamma of half. My handwriting is bad because I'm writing at the bottom of this thing, square. This was initially gamma half square. If you just recall this thing, gamma half, we we evaluated gamma half to be around this minus t square. When we say that, okay, we cannot evaluate this gamma e to the power minus t square alone, so we bring another brother of this e to the power minus u square, and we make multiply two gamma halves to make it gamma half square, right? So gamma half square turns out to be what? This pi. No? So what is gamma half then?
Root pi.
Gamma half is square root of pi. So now you can evaluate any
Sir,
of these.
why you are taking only positive value?
Sorry.
Why
Oh no,
you are taking?
negative values will lead you. I mean, the negative values will lead you to infinities. The negative, in the negative, you put the negative values of this. Suppose you try to figure out what gamma minus 3 by 2 looks like. Now this equation, this integration e to the power minus what, some x to the power minus of what, minus 3 by 2 minus 1, this is minus half. No, this is not minus half. This is what, gamma functions to be minus of 5 by 2 e to the power minus x dx. This integration diverges. This integration does not converge. For x, for this gamma z for z is, if less than is equal to 0, this value is not convergent.
Sir, I am not taking this. I have seen that tau half square equals to pi minus. It
Ah,
could have taken minus root pi also.
I cannot understand. I cannot hear your voices. Sorry.
Means there will be two roots. It's a quadratic.
There will be what?
Two roots.
Two
Number
roots
of, yes, means one will be what plus root pi and another one will be minus root pi. Why we are
from from
neglecting
from from this. Oh, acha. You tell me what is the, oh, acha. I
minus means why
Okay.
we
You are
neglecting
telling me why.
minus?
I mean gamma. This gamma half. This gamma half to the power uh square is pi. So gamma half should be this plus minus root pi. No,
Yes, sir.
gamma half. You see, uh, but you see the way I have plotted. You see, we have plotted this gamma function. You have seen the plot of gamma function. No, we always take, yes, that is true, but the thing is, always the gamma function always takes uh, these positive values. This
So,
is
yes,
this
sir,
is
but I
shaped.
mean the inputs can be positive, but the outputs.
No, 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 no,
You
no,
are
no, no.
not sure
The
about that?
the output also, you see the gamma function, the plot of gamma function should be the was like that. If you recall, you you recall that in the starting of the class, I've showed you the mm, how the plot of gamma function looks like. So
Yes,
anyway, I
but
mean,
that is
uh,
coming from the general definition.
that's true.
Uh,
That is we are just actually the plotting this thing, this integration, this thing, this minus infinity some x to the power of z e to the power of minus z dz, z plus 1, no? No, no, okay, z dz, right? So you are told that this only took, we can only take positive value, I mean positive root of this for some reason.
yes, means there. I don't know if there is only positive or negative. It seems
Okay,
that it is every time giving some positive output, but I don't know whether it will give some negative outputs or not. For this
okay.
case, it could have been minus root pi, but it
No,
means it is
one
not.
thing, acha, acha, no, no. One thing you tell me, just this integration, the integration is nothing but the area under the curve, right? Just some area, area under the curve. If suppose the area is in the negative direction, suppose this direction, then the this should be the curve. Suppose this is the curve, one curve.